In the previous lessons, we learned about measurements in chemistry. Let's look at an example. We have 6.0 kilograms of sodium chloride. Okay, keep that in mind. And a measurement in chemistry has 3 parts that multiply to each other. And let me illustrate that to you. First, we have a number. Okay, a number multiply a standardized unit. Well, this unit right here, kilogram, the prefix kilo is actually 1,000 times grams. And that is being multiplied by or times the chemicals. So they define each other, okay? And that is how a measurement in chemistry works. They multiply each other. Well, this can be expressed by a number multiply a unit and a unit multiplied by chemicals. And why are we multiplying chemicals? That's because different chemical has different values. Sodium chloride is not the same thing as water or just sodium by itself. So that is why we have to be very careful about labeling the substance. This is right here, of course, the chemical formula tells us the substance that we are measuring. Now, understanding the 3 parts of a measurement is extremely important to understand a conversion factor. A conversion factor is a ratio, and you already know what a ratio looks like already. It's represented by a colon or a fraction and so on, of 2 equivalent measurements. Well, what is equivalent? To understand the definition of conversion factor, let's look at some of the common conversion factor. We have 1/4 equal to 5 nickel, and that can be expressed as a fraction. We have 1/4 over 5 nickel. And because they are equal to each other, we can also write them as the other way around. 5 nickel equal to 1/4. And we can do the same thing to all of these right here. And that is the beautiful part about conversion factor. Think of the word conversion. We are exchanging, we are converting from one thing to another. So let's look at an example to see how this is actually solved in a chemical problem. Well, let's look at a very basic problem first that deal with monies. Well, how many quarters are in 25 nickels? So we are converting from what? From nickel to quarter. And the strategy is always the same. You take your given, which is your given clue. Notice how the word given, look at this. Think of this as the given number, your starting values, okay? This is your starting. What are you starting from? You are starting from 25 nickels. And you multiply the conversion factor or multiple conversion factor until you get your desired unit. In this case, what is your desired unit? Well, we want to get to quarter, okay? So let's look at this example. What is given to us? Well, how many quarter are in 25 nickels? So this must be your given right here. This right here is your given. So 25 nickels, okay? So we have 25 nickels right here. Now, think about it. What is the conversion factor that we are going to use? Well, first of all, it needs to have nickels in it, right? And the best conversion factor, of course, will have nickels and quarter in it. In this case, which one has quarter and nickels in it? Well, this one has quarter and nickels in it. Here we have the nickel, and here we have the quarter. And we are going to multiply by that conversion factor. And how do you know which one to multiply? This one or that one? Well, the secret is this. You look at the previous unit right there. See right there? That's nickel. That's the substance, okay? Or that's the unit to be exact. So the unit need to cancel out. Nickel need to cancel out. So what we're going to put here, see how we have 5 nickel right there? We're going to put 5 nickel right there. We just copy exactly from the conversion factor. If this is on the bottom, the other part must be on top, because a ratio only have 2 equivalent measurement. One's on the bottom, the other one must be on top, so 1/4. And look what happened. Nickel and nickel cancel out, just like x cancel out with x. Well, simplify equal to 1 to be exact. Now, all we have to do is do the math. We multiply everything on top, so we have 25 times 1/4 divided by 5. Well, we know that 25 divided by 5 is equal to 5. And what we have in the end is 5/4. And notice how we don't have the nickel anymore because it's simplified and becomes 1. So notice how we convert from nickel now to quarter. Isn't that amazing? And this strategy works for any conversion factor. Let's try another one. Now this one we're going to work with chemistry measurement. Well, 2 moles of water will have a mass of how many grams? So what are we starting with? Notice how I tricked you by putting a 2 right there, right? So that is 2 moles of water. So 2 moles of H2O. This is your starting values. That's your given right there. You are given 2 mole. And how many are we looking for? Well, we're looking for gram. That is our desired unit, isn't it? Isn't that easy? So always start with the strategies. Take your given. In this case, your given is, again, 2 moles of H2O. And notice how I write everything out. 3 parts. The first part, the number, followed by the unit, and followed by the chemical. And time by the conversion factor. Do we know the conversion factor has mole and grams together? Well, right now you don't know, but I gave you 3 conversion factor. You have to choose one of them. Well, which one has moles and grams in it? Well, gram is abbreviated by G, right? And notice how we have G right there, and we also have mole. Oh, look, the first one. So that's pretty easy. And we know that this conversion factor can be written as a fraction of 1 mole of H2O over 18.02 grams of H2O, or the other way around, which is 18.02 gram of H2O over 1 mole of H2O. But that is not that real important when it comes to this. All you have to look at the previous unit right there. This is moles of water, so the mole part must be on the bottom because we need to cancel that out. So we have 1 mole of H2O, and notice how I copy exactly, isn't it? If this part is on the bottom, the other part must be on top. So 18.02 gram of H2O. And look at that, we have our desired unit. Now moles of water simplify becomes 1. And all we have to do now is just plug this into a calculator. We have 2 times 18.02. So let's plug this into a calculator. And all we have to do is multiply everything on top, divide everything on the bottom. We have 2 times 18.02. So 2 times 18.02. And that turned out to be 36.04. And what is the unit that's left? Well, grams of water. 36.04 grams of H2O. And that's all we have to do. Again, multiply everything on top, divide everything on the bottom. In this case, 1, so we can ignore that. Let's try another problem with chemistry measurements. Here we have a sample of 224 and 32 grams of calcium oxide, which is this one right here. Has how many moles of calcium oxide? So of course we know that this is our given right here. We are given the number right there. And what is the unit? It is gram, so that's G right there. And what's the substance? Calcium oxide. And how many moles? That's our unit right there. This is our unit right here. Moles of calcium oxide. And that's why you have to know that the measurement has 3 parts, a number, a unit, and a substance. Well, let's look at the strategy. Always start with our given. And our given is 224.32 grams of calcium oxide. And we need to find a conversion factor that has grams and mole. Remember, gram is abbreviated by G. So here we have grams. Oh, here comes the first one again. So we have grams and mole. And then we just multiply that conversion factor. Notice how we have grams right there, right? So therefore, the gram part must be on the bottom because we need to simplify and cancel it out. So we have 56.08 grams of calcium oxide. And on top must be the leftover 1 moles of calcium oxide, and that cancel out. And we are done because we have our desired unit right here, which is moles of calcium oxide. So that's how you know when you are done with multiplying conversion factors. So let's do it. Multiply everything on top and divide everything on the bottom. 224.32 multiply 1. Well, we can ignore the 1 if you want to, and divide everything on the bottom, which in this case, 56.08. Enter. And our answer is 4. So what we have here is 4.00 moles of CaCO. And that is our answer. Now let's try a similar problem, but we use a different conversion factors. A sample of 4 moles of calcium oxide, again the same chemicals, right, has how many molecules of calcium oxide? So in this case, this again is our given. And how do we know? It is our given number right there. And we are looking for how many, okay, molecules. So the unit is molecules and the chemical is CaO. And let's look at this. The same strategy, always take our given, well, we have 4 mole of CaO multiplied by the conversion factor. Now, we are not going to multiply by this conversion factor because it doesn't have molecules in it. But if we look at the next one right here, we have molecules. But wait a minute, what does that E represent? The E right there, if we remember correctly, that is equal to times 10 to the power of something. In this case, we have E23, that's equal to times 10 to the 23rd power. But we don't want to type all of this out. That's why we use E. So let's look at this. This is moles of calcium oxide. And we look at it, CaO, right? So, of course, this part must be on the bottom. So we have 1 moles of CaO. Notice how this cancels each other out. And if this part's on the bottom, this part must be on top. So we have 6.02 E23 molecules. And you have to spell out the word molecules, okay, of CaO. And look what happened. We have our desired unit right here. And this is right here our desired unit, which is exactly what we are looking for right there. And all we have to do now is plug into the calculator. And that's pretty much it. So we have 6.02. And the way to do E on this calculator, you have to put capital E, which is Shift E, and 23. Notice how it changed to that format for you, right? And multiply by 4. What do we have? We have 2.408 times 10 to the 24th. So again, we're going to replace this with E, okay? So we have 2.41 because we need to round to 2 decimal places. So we have 2.41 E24. Remember this part right here is basically times 10 to the 24 power. And that is molecules of CaO. Now let's try the last problem. In this case, we have a sample of 2.5 moles of carbon dioxide. We'll have how many liters of carbon dioxide at standard temperature and pressure? Well, again, what is our given? Our given is right here. And how do we know? It has a number right there. And we are looking for how many liters, okay? That's the simplest thing we can do is our given and our desired unit. We are looking for a liter of carbon dioxide. And the same strategy, always start from our given. In this case, our given is 2.5 mole of CO2. And time the conversion factor. We have to find a conversion factor that has liter and mole in it. Well, in this case, this one does not count because it has mole but it doesn't have liter. In this case, it has mole but it doesn't have liter, but this one does. So we look at this. If this is mole, this right here must be on the bottom, 1 mole of CO2. And the top part must be 22.4 liter of CO2. And notice how the moles of CO2 simplify into 1. And now we multiply everything on top. So we have 2.5 times 22.4 divided by 1, which we don't care. And the answer is 56.0 liter of CO2. And that is how you use the concept of conversion factor and how you can exchange one measurement of one unit to another measurement with a completely different unit, as long as there is a conversion factor that relate the two units together.